Hello, welcome again guys to this channel. Again, let us have this series LC, the inductor and capacitor connected in alternating current circuit. We are again tasked to get the current drawn. So the values of the following elements are 0.08 Henry and 150 microfarad. It is supplied by a 100 volt 60 Hz source. The circuit diagram is inductor is in series with the capacitor. Again, this is supplied by an alternating current source voltage. The value of this one is 0.08 Henry and 150 microfarad. This source is 100 volt at 60 Hertz frequency. Now we are going again to get the total current. Again, we have this formula by Ohm's law that the total voltage is divided by the resistor or the impedance, since it includes not only the resistor but also the conductor and the capacitor. Now we have here a series connected inductor and capacitor without resistor. To be able for us to solve for the impedance, the total impedance, we have to get the reactances. So the inductive reactance is X of L. This is reflected by the formula omega L. X of L is equals to omega L, or your omega is actually equivalent to 2 pi f, 2 pi times the frequency. So this will be 2 pi times the frequency times the inductance. We have here 2 pi and our frequency is also given as 60 Hertz. So you just place it here, 60 times the inductance, which is 0.08 Henry, 0.08. So you just press your calculator and you can have 30.16 ohms for your inductive reactance. For our capacitive reactance, we have this formula 1 over omega C. Okay, so again we convert omega to 2 pi f, so that would be 2 pi f, which is 60, okay, multiplied by 150 microfarad, 150, so times 10 to the negative 6, okay, converting it to farad. Again, press your calculator, you'll have a value for X of C equivalent to 17.68 ohms. So after finding that, we have now our total impedance equal to the subtraction of X of C minus X of L, or X of that's the absolute value. It can be X of L minus X of C. So the value for this X of C, you have 17.68 minus 30.16, or the absolute value of that. So we mean absolute, if the result is negative, we take the positive value. So that will give us negative 12.48, but that is the absolute value. So we take the positive value, or the absolute value, and right away we substitute it to our formula for getting the total current, which is 100 volts for our total voltage and 12.48 for the total impedance. Now this gives us an IT equivalent to 8.01 ampere. So this is what we are looking for. Thank you.